All right, so a linear equation at some point has this form. It's ax plus b equal 0. So it has that kind of form, ax plus b equals 0. Now the one I just gave you, this one here, does not look like that. This one looks a lot simpler than this is, but at some point you can eventually write this to make it look like this. All right, and the fact that makes it an equation is that it has an equal sign, hence the word equation. The linear part is a fact that the variable, if you look at this variable here, the exponent is 1. Okay? If it was a different exponent other than 1, it would be called the different equation. So in here, you're going to look at quadratic equations, and that has a different exponent. For right now, though, our equations will have the variable will have exponent 1. And so if the exponent is 1, it will be a linear equation. Okay? All right, so what we want to do here, though, is solve this particular linear equation. So we're going to find out what value of x will make this side equal to this side. So it's kind of like when you had a very long time ago, this equation. So this one you can easily look at and tell me what the solution is. What value of x will make the left side equal to the right side? 2. And it might make sense that will be 2, because 2 plus 3 is 5. All right, so when you solve an equation, regardless of the equation, when you solve an equation, you're trying to find the value of the variable that makes the left side equal to the right side. That's the idea. Now this one's simple enough to look at and determine the solution, whereas this one's not. So if you remember, for this one, how can you get x by itself? Yeah, right now you're adding 3, right? So is the opposite. Subtract 3. So you would subtract 3, just like this, and then you would combine like terms. Remember the word combine like terms? And so when I combine like terms, I get x. 3 and a negative 3 is what? 0. So usually you'll just cross this out and put a 0 here. And so x plus 0 is still what? X. And so x equals, and what's 5 minus 3? 2. Okay? Now, when I subtracted 3 from both sides, I was using, and you may remember this, I was using what's called the addition property of equality. Okay, the addition property of equality. So if I add a number to one side, I've got to add a number to the other side. If I subtract a number, I've got to, from the left side, I got to subtract it from the right side. So it's kind of like keeping the equation balanced. All right, now, if we look at this one, though, there's a lot of parentheses in there, right? So you remember one of the things you can do, if I cover, let's say, this part here, and all we have is this expression, what did you do in a previous course to get rid of this parentheses? Use a distributive property. All right, so when I use a distributive property, basically everything inside this parentheses, see, this means negative 5 times, right? So everything inside the parentheses is going to be multiplied by what? Negative 5. Okay, that's a negative 5. And so, first thing I'm doing is using a distributive property. So in the worksheets, you got to make sure that you're doing the same steps like I'm doing here. Okay, don't skip any steps. Do you have the time? You can do the steps. So negative 5 times 2x is negative 10x. Now you got to be careful here. Negative 5 times a negative 3. So a negative times a negative is a positive. So that will be plus 15, right? So I'm just going to rewrite everything else over. 2x plus 1 equal 3x minus 2. So the only thing I did at this point was use the distributive property to get rid of the parentheses. Now, what do you remember you did next? Combine like terms. Very good. So combine like terms. At that point on the left side, How many terms do you see on the left side? Count the terms. How many do you see altogether? How many? 4. Negative 10x, 15, 2x, and 1. So there are 4 terms. Are any of them alike? Yeah. 2 of them here. So negative 10x I can combine with what? 2x. So what's a negative 10x and a 2x? Negative 8x. I can also combine the constants. I'm using the word constants. So remember, the constants are just your numbers, the terms that don't have the variable. So I have a positive 15, and I can combine that with a positive 1. So now that one's easy to deal with. What's 15 and 1? 16. So I get negative 8x plus 16 equal 3x minus 2. So what you're doing to solve this equation is you're doing processes to get to some point where you get x equal some number. Just like we did here, where I got something look like this to something looks like this. So you're doing a process to get to that point. So whatever the solution is to this is also the solution to this, is also the solution to this. I'm getting to that particular solution. Now, if you look at this, you have variables on both sides, constants on both sides. So when solving a linear equation, do you remember what the next process is? Very good. Get the variables to one side, constants to the other. It does not matter which side you bring the variables on. Does not matter. Or which side you bring the constants on. Does not matter. So let's go ahead and bring the variables to the left. So meaning I want to bring the 3x term to the left side. So remember that addition property of equality, that's what you're going to use next. So if I want to get rid of 3x, is adding 3x going to help me? No, because 3x plus 3x is 6x, right? I want to get that to be a 0. So what should I do? All right. Now notice that I'm aligning my like terms to make it easier for me. So I'm going to subtract 3x here. What I do to one side, I have to do to the other. Remember that I'm using the addition property of equality. So if you add something to one side, you have to add it to the other. So if I subtract 3x from the left side, from the right side, I've got to subtract it from the left side. But I'm going to align them and put it under its like term, right here. Now, once you use the addition property of equality, what's the next step that usually occurs? What is the next step that you think that? Okay, so there's a better word than that than saying you have to solve. You have to do what to those two? Combine them. All right, so usually when you use the addition property of equality, the next step is to combine like terms. So what's a negative 8x and a negative 3x? Negative 11x plus 16 equal, what's 3x and a negative 3x? 0, right? 0. Because 3x minus 3x is 0. And what's 0 subtract 2? Negative 2. So that's where I'm at. So I brought the variables one side. Now I've got to do what? Bring the constants to the other side. All right. So right now I'm adding 16, so I'm going to use the addition property of equality again. So what do I need to do to both sides? Subtract 16. So remember, in this case, that's the addition property of equality. And again, what do you think is going to be the next step? Combine like terms. So when I combine like terms, a positive 16 and a negative 16, 0. And all I have left is negative 11x equal, and what's a negative 2 and a negative 16? Negative 18, so that's where I'm at. Okay, so almost done in terms of finding the solution. So whatever the solution is for this is the same thing as this one, is a solution for this one, is a solution for this one, is a solution for this one. And how can I find a solution to this simpler one right here? Yeah, so now at this point, see, I'm trying to get x by itself. Right now, if you look at this, this is read as negative 11 times x, right? And so what's the opposite of multiplication? Division. So I'm using what's called the multiplication property of equality. And we normally use this last. We use this last. So multiplication property of equality. Right? So if I want to get the variable x by itself, since I'm multiplying by negative 11, I'm going to go ahead and rewrite this over. So if I'm multiplying by negative 11, I'm going to have to divide by negative 11. So if I divide the left side by negative 11, I have to divide the right side by negative 11. Remember, the whole point was to get what term on this side? X. So the whole idea was to get x by itself, right? Just like we did here. Now notice this, when we did the easy one earlier, what's that coefficient right here? 1. That coefficient is 1. At this point, the coefficient was not 1. What was the coefficient? I'm using the word coefficient. Negative 11. So you want the coefficient, though, to be what coefficient? 1. All right, so let's see if that's what we got. A negative 11 divided by negative 11 is what? 1. Now you see how I cross this out here and how I cross this out here? That's two different things. When I cross this out, make sure you indicate what that really is. So when I cross this out, that really was what term? 0. When I cross this out, that's what factor? 1. Because negative 11 divided by itself is 1. 1 times x is x. And then you got to remember now that a negative divided by negative is a positive. That's important. So don't leave it as negative divided by negative. You have to remember that a negative divided by negative is a positive. And you can leave it, though, as 18/11ths. Now remember in courses a while back, what kind of fraction is 18/11ths? Improper. So that's an improper fraction. In that particular course, you are usually asked to write an improper fraction as what kind of number? A mixed number. All right, and so basically what you did was you said 11 into 18 goes how many times? 1. 1 times 11 is 11, and you subtract, you got what remainder? 7. So this, you could say also, if you want to, that this is 1 and 7/11ths. Okay? So that was number 1. So that's the processes. Remember, there are many properties you use. Addition property of equality. We use the distributive property. We combine like terms throughout the process. And at the end, we use the multiplication property of equality. So this solution right here, the value of x is the solution to the original equation. Okay? All right, let's look at number 2. All right, number 2, we have this equation. All right, so number 2, we have this equation. What kind of equation is this? It's important as we go through the course, you know your equations. What kind of equation is this? It's a linear equation. So at some point when solving a linear equation, you're going to bring the variables one side, constants the other. But there's a lot of other things you got to do before that. So based on our previous example, what's the first thing you think you're going to do? Distributive property. Now, a mistake people make is this. See this right here? They see 8 minus 2, and they want to say that's 6. And then they distribute the 6. That's incorrect. That's not correct. Because remember, you got to remember the order of operations. Order of operations. Yeah, so your order of operations, so remember, please excuse my dear Aunt Sally. In particular, though, so remember that multiplication division is the same level, and you do it from left to right, whichever one shows up first. And then addition and subtraction is a lower level, right? And you do it last. But you still do it from left to right. So if addition shows up first, you do it. If the subtraction shows up first, you do that first. So if I look at this right here, this is what operation? Subtraction. This is what operation I'm pointing to? Multiplication. What should I do first according to this? Multiplication. So multiplication comes before subtraction. So I got to distribute first. All right, so don't make the mistake and do the subtraction first when you should do what first? Distributive property, because it involves multiplication. But I'm going to leave it, though, as -2. So I'm going to distribute the -2. So I get 8, bring down the 8, and what's -2 times 3x? -6x. What's -2 times a +1? -2. That's what I got. Now this side's easy for people because there's no issue here. You distribute the -3. So what do you get? -3x plus 6 plus 4. So that when you do the worksheet, just do it just like that. Make sure it's neat. Do one thing at a time. So here all I did was distributive property. Okay, now once we did distributive property, what's usually the next thing that's going to happen? Usually combine like terms. Can I do it in this case? Yeah. On the left side, how many terms do you see? 3. 8. What's the other term? -6x. And what's the other term? -2. So how many terms? 3. Can I combine any of them? Yeah. The constants. 8 and a -2 is what? +6, right? +6. It does not matter, though. It does not matter. And I'm going to go ahead and say it here. It does not matter whether you say 6 minus 6x or someone else could have written this as what? -6x plus 6. Does not matter, right? It's up to you how you want to write this, but normally what some students prefer to do is put the variable term first. So I'm going to go ahead and write this right here as -6x plus what? 6. Equal. How many terms are on this side? Can I combine any of them? And what are those called? Constants. So +6 and a +4 is a +10. So this becomes -3x plus 10. Someone else could have, if they wanted to, had said 10 what? -3x. All right, so -3x plus 10 is the same as 10 minus 3x. But again, we tend to put the variable terms first. You don't have to, but it sometimes looks easier for students. All right, so I have variables on both sides, constant on both sides. So what's the next step? Say it again? Okay, so we're using, what property is that called? Addition property of equality. All right, so using addition property of equality. So let's just go ahead and bring them to the left side. So it's adding 3x and subtracting 3x going to help? Adding 3x. Because the -3x and a +3x is what? 0. But what I do to one side, according to the addition property of equality, I have to do to the other side. Now, once I do the addition property of equality, usually what's going to happen next? Combine like terms. So what's a -6x plus 3x? -3x plus 6 equal, and over here what's left? 10. All right. What's the next step? Say it again? Subtract 6. What property is that called? The addition property. So this was the addition of property of equality, and this was the addition of property of equality. Usually when you do the when you use the addition of property of equality, what's the next step? Combine like terms. Positive 6 and a negative 6 is 0. So what's left on this side? Negative 3x equal. And notice if you go back to everything we've done, I didn't for the most part do it here, but I tend to align the equal signs. Right, so the equal signs are right under each other. You don't have to make sure it's directly under each other, but it does help. All right, and what's 10 subtract 6? 4. All right, so almost there. What's the next step? Divide both sides by negative 3. What property is that called? Multiplication property of equality. All right, so we'll go ahead and rewrite it over. All right, so right now I'm multiplying by negative 3. The opposite is to divide. Because remember, I don't want a coefficient here of negative 3. I want the coefficient to be a positive 1. So to get that to be a positive 1, since it's multiplication, I'm going to go ahead and divide. Because negative 3 divided by negative 3 is what? 1. But remember, the multiplication property of equality, just like the addition, what you do to one side, you have to do to the other. All right, and so this left side becomes just what? Just x equal. And then is it going to be a positive or a negative on this side? Negative, because a positive divided by negative is a negative. For what? Thirds. Or if you want to, you can write it as a mixed number. So 3 into 4 is 1. 1 times 3 is 3. Subtract, you get remainder of 1. So this becomes negative 1 and 1/3. Yes?
The test's multiple choice.
Just like this.
Okay, so we can write either one.
Say again?
So we can write either one. It wouldn't
Oh,
be a
yeah.
problem.
No. Now, in my math lab, sometimes they will tell you write as a mixed number, so always read the directions carefully in my math lab. Because if they tell you to write a certain way and you don't, even though it's still correct, you're not going to get credit for it. So always read the directions carefully. They'll usually tell you how they want the answer written. Okay, now let's look at this equation. So just kind of reviewing an easy kind first. Let's suppose you want to solve let's say we had x divided by 3 equal, let's say 2. You can look at this and tell me what the solution is. And I made it that way so you could tell me what it is. What's the solution here? Huh? 6. Because 6 divided by 3 is what? 2. But they're not always going to be that simple, right? So you got to use mathematical process to determine what the solution is. So what's another way I can actually do this rather than just looking at and guessing at the answer? Okay. So right now you'll notice that in the previous problem here, to get the variable by itself, to get the coefficient of 1 here, right now I'm multiplying by negative 3, right? And the opposite of multiply by negative 3 is to divide by negative 3. Right now, what am I doing here? Dividing by 3, right? And so what's the opposite of dividing by 3? Multiply by 3. So one of the things you're going to see when we get into a more difficult problem is that when you have fractions, meaning that you have something in the denominator that's other than 1, you want to multiply both sides by the LCD. So remember, LCD stands for least common denominator. Now this one's easy enough because you only see one denominator there that's other than 1? What's the denominator that you see? 3. So what you do one side, you do the other. So to get rid of this fraction, I'm going to multiply both sides by the LCD. So it's going to look like this. We're going to rewrite it over. I'm going to say times 3. What I do here, I got to do here. So say times what? 3. All right. Now, you got to simplify this side, though. Now, remember, this 3 right here, this right here is really 3 over what? 1. All right. I'm going to remind you about something in a previous course. If I have, let's say, 6 fifths times 10 twelfths, let's say. And in a previous course, you were multiplying these fractions. Before you multiply these fractions, what did you usually do first? Reduce. You reduce first. So you could say, all right, I have this 6 here. I can reduce it with which number down here? 12. So 6 into 6 is 1. 6 into 12 is 2. What else could you reduce? 5 and the 10. I could even do the 10 and the 10 and the 2, right? I'm going to do the 5 and the 10 for right now. 5 and the 5 is 1. 5 and the 10 is 2. And then at that point, you can even go further, but at that point, you would probably say 1 times 2 is 2. 1 times 2 is 2, and that's just what? 1. All right, so that's just kind of review from a previous course. That's what you're going to use here. What can I reduce over here? The 3. So 3 to 3 is 1. 3 to 3 is 1, right? And so once you reduce, then you multiply the numerators. What's 1 times x? X. And then multiply the denominators. What's 1 times 1? So that's just what? X. So x equal 6. Okay? So that's going to take us to this one now. So I'm going to go ahead and write this as number 3. Number 3. So go ahead and write this down. This is number 3. So let's say we had 2/3 t minus 3/4 equals a half. So 2/3 t minus 3/4 equals a half. And so the way you want to do, now there's other ways to doing this, but the way you want to do this in here is to multiply both sides by the LCD, because that's going to be important later on as well. So let's go ahead and multiply both sides by the LCD. So what are your denominators that you see? 3, 4, and 2. What's the smallest number that 3, 4, and 2 go into? You want to use the least. 12. Now, if someone said 24, that's fine. It's not the least. But the idea, remember, is to get what numbers down here in its place. What number do I want? 1. So what if I need this to be a 1, then whatever I multiply it by, it better be divisible by 3. So if someone said 24, is 24 divisible by 3? Yes. Is 24 divisible by 4? Yes. Is 24 divisible by 2? Yes. So there's an infinite number of ways to get rid of these denominators and make those 1s. But you want to use the least. So what's the least? 12. And before we go on, let's make sure it makes sense. Will 3 go into 12? Will 4 go into 12? Will 2 go into 12? Okay. So that's what you got to look at. All right, now here's what you can do, though. So remember, what you do to one side, you have to do to the other. How many terms do you see on this side? 2. So since there's more than one term, I'll put that in parentheses. You have to put that in parentheses. So you're going to say this. 2/3 t minus 3/4 equal 1/2. So all I did at this point was just put that in parentheses because this would be important. I didn't put the other one in parentheses because how many terms did you see here? Just 1. Now let's go ahead and multiply both sides by 12. So you say times 12 times 12, just like that. Okay? Now, remember the previous 2 we did, meaning these 2 right here. What was one of the things we did? Get rid of the parentheses. What did I do? Distributive property. So you see I introduced parentheses. Now I've got to get rid of them. So how to get rid of these parentheses? Use the distributive property. So this becomes 12 times 2/3 t minus what? 12 times 3/4 equals 1/2 times 12. So remember a while ago when we found the LCD, I said to double check, make sure before you go any further, you ask yourself, will 3 go into 12? So you better see a 12 here. Will 4 go into 12? You better see a 12 here. And then will 2 go into 12? You see a 12 here. So every term has to be multiplied by what? 12. Okay, now we're going to reduce. Reduce. How can I reduce this right here? Remember, you can reduce. If you multiply by the LCD correctly, you should be able to reduce, meaning that I can make this what factor right here. Instead of 3, it will become a what? 1. 3 into 3 is 1. 3 into what? 3 into 12 is 4. Okay. Now what's 4 times 2? So this becomes what? AT. Good. So you see, you no longer have a fraction on this right here. Now we go here. If I'm doing this correctly, this 4 better be a what? A 1. So here's what we're saying. 4 into 4 is 1. 4 into 12 is 3. And 3 times 3 is 9. So this becomes minus what? 9. Good. Equal. If I'm doing this correctly, this 2 should become a 1. 2 into 2 is 1. 2 into 12 is 6. So this becomes what? 6. So notice I went from something that had fractions to a linear equation with no fractions. Okay? All right, so remember the first thing you got to do is find the LCD and then multiply both sides by the LCD. You may, if there's more than one term, and there usually will be, you may have to introduce parentheses. But basically what's happening is that, see how many terms do you see altogether right here? No, right here. 3. 2 on this side, how many on this side? 1. So at some point, what's going to happen is that all those 3 terms better be multiplied by what? 12. You see that? Goes from here to here, 12. And then you reduce, basically I reduced, and I get this. So now we had an easy point. What's the next step? Add 9 to both sides. Oh, someone said combine like terms, because we did say usually when you do this distributive property, you will combine like terms, but there weren't any terms to combine, right? On the left side right here, nothing are alike. On the right side, there's just one thing, so there's nothing to combine it with. So then the next step is to add 9 to both sides. Subtracting 9 is going to help, because what's a negative 9 and negative 9? Negative 18. So you want this to be a 0. So this is now 0, so I get 8t equals 15. What's the next step? Divide both sides by 8. And so 8 divided by 8 is 1. So this becomes t equals what? 15/8. Okay. Or what? Okay. Or 1 7/8. All right, let's do one more. And let's look at this one. We do one more. All right, you have x divided by 5 plus 2 equal x divided by 3 minus 5. So again, there are things you could do first, but let's just go ahead and do the same process we did with the previous one. I want to clear the fractions. So basically, if you look at your denominators, you can see some denominators here. You see a 5, and what else do you see? A 3. Now, this 2, the denominator is really 1, right? 2 over 1, negative 5 over 1, but don't forget about those. You're only looking at these right here. What's the smallest number that 5 and 3 go into? 15. Now, that's the least. There's not the only common denominator, because 30 also, right? And there's 60, 90, and so on. But you want to use the least. So the least is 15. All right. Now, remember what we did previously. And you can skip that part if you want to, as long as you know that how many terms do you see here altogether? 4. All 4 terms has to be multiplied by what? 15. And it kind of makes sense, because if I did put this in parentheses, because how many terms do you see here? 2. It goes back to the one we did a while ago. Remember how I put this side in parentheses? So if I did, let me just go ahead and do down here. So if I did put that in parentheses and then multiply by 15, and then distribute, in that same 15 times x over 5? And then plus 2 times what? 15. Okay, good. So if you just want to go ahead and skip that parentheses part, that's fine, as long as you know that all 4 has to be multiplied by what? 15. So you're going to say 15 times what? X over 5. Plus 15 times what? 2. Equal, what do I write? 15 times what? X over 3 minus, and then 15 times what? 5. Okay? All right, now let's reduce. I need this 5 right here to be a what? 5 and a 5 is 1. 5 and a 15 is 3. So what does this become? 3x. Plus 15 times 2? Okay? Equal. I need this to be a 1. 3 to 3 is 1. 3 to 15 is 5. So this becomes what? 5x. And then minus. What's that? 75? 75? All right. So notice I got rid of the fractions. What's the next step? Yeah, bring the variables to one side, constant to the other. Let's go ahead and bring them to the left. Although you could have brought to the right, the variables to the right, doesn't matter. Either you're going to subtract 3x from both sides, or you're going to subtract what? 5x. Does not matter. Which one do you want to do? 5x. All right, so you're going to subtract 5x. What I do to one side, I do to the other. Then what's the next step? What you have, what do you think the next step is? Combine like terms. Now this is where some of you are going to mess up. What's 3x and a negative 5x? Negative 2x. Some students will say 2x. That's not correct. It's a negative 2x. Plus 30 equal. This is 0. What's left? Negative 75. A couple more steps and you're done. What's the next step? Subtract 30 from both sides. And so combine like terms. I get negative 2x equal a negative 105. And then finally do what? Divide both sides by negative 2. A negative 2 divided by negative 2 is a positive 1. 1 times x is x. A negative divided by negative is a positive. You can leave it as a mixed number. I'm sorry, improper fraction. Or, if you want to change it to a mixed number, you can say 2 into 10 is 5. 5 times 2 is 10. Bring down the 5. 2 into 5 is 2. 2 times 2 is 4, or the remainder of 1. This is 52 and 1/2. Okay. Okay, so we looked at 4 main problems and then some other simpler ones though. But the main ones is the 4 that are numbered. So you can use that when looking at your worksheet. So